This is the second physics lab, and it is about lines of charge. In it, we will be gathering data about charge tapes and how charges may interact with one another as a line of continuous charges, and we will determine the necessary charge to make the top tape float. We use Newton's first law, the law of inertia, the electric force formula, and electric field calculated along a rod. The results were that the required charge ended up being around 21.57 e to the e negative 9 coulombs, and the magnitude of the electrical and gravitational forces were identical at 0.0018 newtons. So for the computational model, the mass of the tape was 0.185 kilograms, the length of the tape was the same, just in meters, and it began floating at zero point zero 0.02 meters. Some necessary assumptions were that we ignored air resistance on a moving object. We assumed that each tape had identical charge distributed uniformly across the line of tape, and the force of the hand was part of the surroundings with reference to the bottom tape, and was therefore irrelevant to the top tape system, because for the top tape, the things that were in its surroundings were just the bottom tape and Earth itself. And the line of charges is similar to charge distribution across a rod. So going over to the code, we see that here's the mass, and then this is estimated net charge. Here we're just setting up a function that will tell the program how to calculate the electric field from each given particle at its location, or at each charge. This is just creating a line of charge for visualization. And here are the where the tapes and their charges will be aligned. So I changed this value to be 0.02 to reflect where the tape begins to float. And this is just to scale the arrows. This is more arrow scaling. And this is setting up a variable and initializing it. Then when we go into a for loop, we initialize another variable so that the program is able to call that up later within the embedded for loop. And we're just editing it, setting it into DE, and then our overall electric field at that specific charge point is going to be called by this variable and then the variable that we initialized earlier. And it's more or less the same for the force. Then all of this is just visualization. So when we run the program, this is what it looks like. This top arrow is the electric force, and then this is these green arrows are the electric field at those individual points. This is the arrow for gravity, or the gravitational force. And as you can see they're equivalent. So what if each of the tapes had been modeled as a single point charge? If the tapes had been each modeled as a single point charge, then their charge was Q equals 8.977 e negative 9 coulombs. And I just took this value from the prior lab and modeled as a line of charges. As you can see, they were 21.57 e negative 9 coulombs. And when I put them in a ratio against each other, there's just twice as much charge calculated on the line of charges as compared to the single point charge. And these estimates differ because one is an integral, the accumulated charges across an area, and the other is just a simplification where all charge is assumed to be in the center of the object, and therefore it only really finds the extent of charge for a single point. The value calculated for the line of charges is closer to the real value because it takes into account that there are electrons throughout the object, and as a result, they all react in different magnitudes to a specific observation point with respect to their location to it. And if I could do this lab again, I think personally I would change how some of the variables, like just the naming, because it was really confusing for me to go through and actually understand what they were doing because the names were so long, but I just wasn't confident enough to really mess with the code, so I'll do that next time.